Hello everyone, we are Mars, Jessica, Kitty, Nako, and Jasmine. We come from the Queen Elizabeth School All Students Association Secondary School from Hong Kong. Our research is about the use of brine shrimp to test for water pollutants. Deep Bay is a traditional oyster culture zone in Hong Kong. People may have cultured oyster in Deep Bay for over 700 years. However, in the past decade, the heavy metal and microplastic pollution have imposed serious threats to oyster industry. Water pollutants absorbed on the surface of microplastics and sediment can be taken up by marine organisms, like oysters. These pollutants may accumulate along the food chain and then affect human health and ecological balance. Heavy metals cause damage to the internal organs. Environmental hormones such as triclosan and bisphenol A disrupt the endocrine system. Some lotions contain the chemical like oxybenzone and ethinoxate that may lead to coral bleaching.
In this investigation, we try to test whether brine shrimp is sensitive to environmental pollutants, and then test for whether it can be used as a biomarker for water pollutants. Brine shrimp is a group of Artemia species that live in salty water, such as Salt Lake. Its life cycle is short, and it can be cultured easily and economically. We used this case to culture brine shrimp nauplii from eggs. It takes 1 day for the egg to hatch. The nauplii are freshly collected and then are used to do toxicity tests.
We add nauplii into different concentration of heavy metal solution in small plastic petri dishes. With the use of dissection microscope with video capturing camera, we count for the number of deaths in active and active nauplii. The death rate can then be determined. With the use of AAT BioQuest LC15 calculator, we could determine the lethal concentration 15.
In summary, brine shrimp nauplii had different sensitivity to different water pollutants. It is also shown that brine shrimp nauplii were the most sensitive to chromium, copper, bisphenol A, and oxytocin. According to the results of the death rate of adult brine shrimp, nauplii were relatively more sensitive to heavy metal. We also did some field studies. We therefore went to 3 different sites of the oyster cultural zone, that are Sha Kyu Chun, Hang Hao Chun, and Pak Nai, to collect sediment samples. As you can see in this slide, Sha Kyu Chun is also sparsely populated. In Pak Nai, it is just next to the accredited fish farm, and it is far away from major pollutant source. However, Hang Hao Chun is more densely populated than the other 2 sites, and it is also close to the pier and seafood market. Thus, a high level of environmental pollutants is to be expected.
With reference to the method suggested by around 2014, sediment samples were dried and particles that are less than 0.25 mm were obtained by sieve. We extracted the exchangeable heavy metals and some organic pollutants with 1 m neutral sodium acetate with a 37 degrees shaking incubator for 1 hour. The sediment extracts of the 3 sediment samples and were used to do the toxicity test. When the sediment samples were tested with brine shrimp nauplii, the extract from Hang Hao Chun showed a higher death rate than that of the Sha Kyu Chun and Pak Nai, and the death rate is similar to 1 ppm BPA. Hang Hao Chun is located near the residential area and the Lau Fo Shan seafood market, whereas Sha Kyu Chun and Pak Nai are sparsely populated. Therefore, Hang Hao Chun is expected to have a higher level of environmental pollutants. From this result, it supports the idea of using brine shrimp nauplii to test for the toxicity of sediment samples. In summary, our method to use brine shrimp nauplii to test for overall toxicity of sediment extracts is low cost, simple, and safe. It may be used to monitor the change in environments. Last but not least, we want to express our greatest gratitude to SSPC, our teachers, technicians, and our groupmates to support our project.